Hi, and welcome to your third day of asynchronous learning. And today I'm going to be showing you about how you're going to be finding some stars outside. Now, a couple things that you need to know. You're going to be using some computer software to help understand how stars that are visible in the night sky might be different in terms of comparing and contrasting them to our sun. So this is a formative. Your target is BP. We're going to be really thinking about models. I can develop and use models to show and or predict relationships. Our model being our sun compared to other stars in the night sky. So you're going to be using this website, or you could use an app on your phone called Sky Guide, where you're going to be able to find other stars that you can visibly see outside. Now, you want to do this maybe later at night, so 7 or 8 o'clock at night. It should be a clear night, or you could wake up super early in the morning, which I know as teenagers that might be a little bit tricky. The further you can be away from man-made light, the better you'll be able to see the stars. And for each star that you find out, you're going to be recording some information in the table I'll show you in a minute. And you're also going to be clicking on the Wikipedia page and using that for some information. So let's go and check out our app. So this is the Stellarium web app. And the cool thing is that it is based on your location. So you can drag and adjust your location anywhere where you live. So you can have a really good sense of when you go outside and you're looking north, south, east, or west, where are you? So I'm going to go to Foster Farm Road. No idea where it is, but that's where I'm going. And then the great thing is that you can change. You have a 120-degree field of observation. You can make it a little bit darker. You can make the landscape disappear. You can add an equatorial grid so you have a better idea of where you are in the world. And you can also look at deep sky objects. So your goal is to be able to find some stars in the sky that you're interested in. Right now I'm looking west. So west would be towards Mount Mansfield and Lake Champlain. But I can look north, can see the International Space Station. I can see east with the moon and Capella and Sirius. Then I can look south and there's Mars. Now each of these stars you can click on, and here's Aldebaran. And Aldebaran, for example, is a giant star that's 65 light years away from the sun. And I want to learn some more information about Aldebaran. So Aldebaran is part of the Taurus constellation. It's a really large red giant. And we're going to learn some information about it. So when you go and find your stars, you're going to open this link right here, the stellar spreadsheet. And in the stellar spreadsheet, you're going to put your name. You're going to put your star name, and within that you want to link it to the Wikipedia page of your star. And then you're going to be finding the information about your spectral class, color UV, age, mass, radius, luminosity, absolute magnitude, and surface temperature. Notice all of these numbers don't have letters unless it's G2. So I'm just going to do Aldebaran right now to help you think about how you can do this really efficiently and quickly. So I'm just going to say Ethan. I'm going to go to Aldebaran. I believe I spelled that right. Aldebaran, not Aldebaran. All right, spectral class, where can I find that? So I'm going to go back here and, ooh, it's a K5. Awesome. So I only need the letter and the number. Color UB. So we want to find UB color index. It's a positive 1.92. Age, how old is it? So we're going to find that probably right there. 6.4, positive 1.4, negative 1.1 GYR. Yikes, that's a lot. So it's a billion years. It's 6.4 billion years, but also some people think that it might be slightly older or slightly younger. If you get a range, just take the average number. So I'm going to put in this 6.4. Solar mass. 1.16. Notice there's the 0.07. Again, there's a range because scientists can't go 65 million light years away and measure it. So I'm going to put in the 1.16. Solar radius. 44. Wow. 0.13. And the more specific you can be with your numbers, the better. Luminosity. 439. Absolute magnitude. We're going to find right there, negative 0.641. Hello, I'm recording a video right now for Async lesson, just so you know. Everyone, this is Evan. He's in the apes class. And surface temperature, which I can find, so many tabs open, somewhere around here. 3,900 Kelvin. So that's all the data that you want to find about each star for now. And if you have questions about any data that might be missing, or maybe you have your age in millions of years, just let me know and we can make some fixes to that. So after you find your stars, and you want to do at least 3, you're going to put that information also in this table. And then you're going to write some quick specific comparisons to our sun using data from your left column, but also the information that I've given you right here about Sol, our sun. So for example, if I was comparing my star to Polaris, Polaris is an F7 star, meaning it's further along in the spectral classification. It's older, but it has a mass of 5.7, so it's older than our sun. You could also think about making comparisons of stars that are similar or different. So notice Aldebaran is a K5 star. It's older than our star and it's a lot more red, but it has the same mass roughly as our sun, but it's 44 times as large. That's crazy. Its luminosity is also 430 times bigger than our sun. So it's making 430 times more energy per second than our sun. So those are the comparisons and contrasts that you can make for your stars. Let me know if you have any questions or you have any problems, and have a good day.